Hey guys, in this lesson we would understand what are the basics of chemical equilibrium. First, let's understand what is equilibrium actually. Equilibrium is just a state that occurs in reversible reactions. Now, what is a reversible reaction? Let's take an example for that. Nitrogen gaseous reacts with hydrogen gaseous to give NH3, that is ammonia gaseous. When we balance this reaction, there should be 3 here, there should be 2 here. So this is basically N2 gaseous plus 3H2 gaseous gives us 2NH3 gaseous. This reaction, when we start the reaction, we put in nitrogen and hydrogen in the reaction chamber that forms ammonia. Once certain amount of ammonia gets formed, then the reaction starts taking place backward as well. So ammonia has a tendency to again break down back into nitrogen and hydrogen. So when a reaction can occur both in forward and backward directions, that reaction is called a reversible reaction. Therefore, this reaction is a reversible reaction. And equilibrium is a state seen in reversible reactions only. In other words, equilibrium is a condition that can only be seen when the reaction happens both in forward as well as in backward directions. So basically, this reaction happens in 2 different ways. One is the forward reaction where N2 and 3H2 gives us NH3. This is called the forward reaction. I'm writing it as FWD. The other reaction is called the reverse reaction, and that is the reaction in which NH3 breaks down into N2 and 3H2. Now we have learned in chemical kinetics unit that a reaction when proceeds, it proceeds with a certain speed. That is called the rate of reaction. Forward reaction has its own rate defined as rate of forward reaction. Rate means speed in which ammonia is being formed. So that is called rate of forward reaction. Reverse reaction is the rate or the speed in which nitrogen and hydrogen is being formed. When both the forward and backward rates are equal, or when both the forward and reverse rate of reactions are equal, that condition is called state of equilibrium. That means the speed at which the forward reaction and the speed at which the reverse reaction is happening is going to be same. That condition is called equilibrium. We can also understand this with a graphical diagram. So if this is the time taken for a reaction to occur and this is the concentration of the reactants and products, because first the forward reaction is what we want to happen. That's why we started with hydrogen and nitrogen. The reaction was nitrogen plus 3 hydrogen gives us NH3, that's 2 times gaseous. So we have 3 times hydrogen, we have 1 time nitrogen, or 3 moles of hydrogen, 1 mole of nitrogen. So hydrogen is at a higher point. This is hydrogen concentration, and let's say this is nitrogen concentration. Now we know when the reaction is going to proceed, the reactant concentration is going to decrease. Both hydrogen and nitrogen are reactants, so their concentration is going to decrease. And the product concentration, because initially we did not put any of ammonia, so it was 0. Ammonia starts at 0 and then it starts increasing because hydrogen and nitrogen are forming this ammonia. But at equilibrium, what happens? Ammonia concentration becomes stable, hydrogen concentration becomes stable, nitrogen concentration becomes stable. So hydrogen and nitrogen never come down to 0, ammonia never go up to infinity. And the reason is that because the rate at which nitrogen and hydrogen is forming ammonia, the same rate ammonia is again breaking down back into nitrogen and hydrogen. So there'll be a condition when all of these 3 concentrations will become standstill or they will become constant. This condition is equilibrium condition. So these 3 concentrations will then keep proceeding parallel to each other. So they will just be at the same level when we check their concentration values. They will always stay at the same level. Now we can take the scenario of equilibrium same as the tug of war situation. You know, when in tug of war 2 people are pulling the rope, when 2 people are pulling the rope with equal force, the tug of war rope seems not moving because both the people are pulling the rope with same force, so it seems nothing is happening to the rope, as the rope is neither moving to one direction nor moving to the other direction. Similarly, in a state of equilibrium, it seems that the reaction has stopped taking place because the concentrations become standstill or they become constant. But technically, equilibrium is not a condition when the reaction has stopped. The reaction, that is this, is still taking place, but the forward reaction and the backward reaction speeds are same. Therefore, we say equilibrium is dynamic. Dynamic means moving. That means the reaction concentrations are changing, but we cannot see them changing because the rate at which ammonia is being formed, the same rate it takes to break down ammonia to form nitrogen and hydrogen as well. Now, this is an example of a chemical reaction. So this is equilibrium attained in a chemical reaction. Can we see equilibrium in physical reaction? Physical reaction means state changes, and the answer to this is yes. Let's take up an example of iodine that is in solid condition. When we heat it up, it changes to iodine gaseous. Now this iodine gaseous has a tendency to again get converted back into iodine solid. So here what's happening is no new products are being formed. It's just that the solid state is changing to gaseous state and gaseous is changing back to solid state. So this is a condition of equilibrium in physical reaction. So the rate at which the solid is changing into gas, that is equal to the rate at which gas is changing back into solid. And when we look into the reaction chamber and the beaker in which this reaction is taking place, it seems that a solid and a gas, it seems that no reaction is taking place because physically what we see in the beaker is exactly same before we see it, after we see it. So when we look into the beaker in which this reaction is taking place, it seems that no reaction is taking place or nothing is happening because this equilibrium has been attained. And when equilibrium is attained, physically we see no change in the reaction mixture or reaction chamber or the beaker. Now equilibrium needs certain conditions. Therefore conditions necessary for equilibrium are as follows. I'm going to use this as a short form of equilibrium. One is that the system must be closed. What does it mean by closed system? Is that let's say in a beaker there is iodine present in solid state and we are heating it up, so it's forming gas. Now we put a lid on top of it. What is this lid going to do is it's not going to let these vapors go out. So when the vapors do not exist, when they touch the lid and the lid is cold enough, these vapors again change back to solid iodine. If the system is not closed, if we do not provide a lid here, then the vapors would exit, and if the vapors exit, there is no gas left that can change back to solid iodine. Therefore, the system must be closed for equilibrium to occur. Second condition is, we have already discussed that condition, that is the rate of forward and backward reaction should be equal. That means the speed at which the forward and the reverse reaction takes place, that should be same. If forward reaction is taking place fast and backward reaction is taking place slow, then we would see more of the product forming in the reaction mixture. So for equilibrium to occur, we should not be able to see any physical change happening in the reaction mixture basically. Third is, no external changes should happen while the reaction is taking place. So that means if we want equilibrium to establish in a particular reaction, we should make sure that we do not bring any external changes. External changes means any heat change. So basically no heat change. We should not change the temperature. Whatever temperature initially is provided, that should stay constant. We cannot change pressure. We cannot change volume, and any other thing that we want to add in or we want to remove, we cannot do that. So no concentration changes. That means once we put in or once we let the reaction start happening and we close the lid, we cannot open the lid again and then make any changes into the reaction mixture. Otherwise, the equilibrium will get disturbed.